5, 6, 7, 8, 9, 10, 11, 12, 13, 14,
Math is often referred to as the universal language.
16,
It is perceived to be
17,
something
18,
pervasively and
19,
timelessly true.
20.
However, in fact, like any other language, math has diverse cultural and regional distinctions, and has changed a lot over the years to become the system we recognize today.
واحد اثنين ثلاثة أربعة خمسة
Before writing,
ستة
early civilizations
سبعة
used their hands to count
ثمانية
and keep track of
تسعة
numbers.
عشرة
The base 10 numeric system popular today stems from humans counting their 10 fingers.
שבע, שמונה, תשע, עשר.
Uno, dos, tres, cuatro.
However, not even counting was standardized globally. When people around the world began writing and recording their numbers, it was proved that other systems, such as base 20 and 60, also existed and functioned in important societies.
8, 9, 10, 11, 12.
Babylon, the first human civilization, developed a base 60 number grouping system. Their numbers were represented by two symbols, the first equal to 1 and the second representing 10. Later, in Egypt, a base 10 system was employed. Their numerals extended to include 100, 1,000, and 10,000. Egyptians' study of numbers was extensive and revered. Mayan civilization also invented a unique way of presenting numbers. They had a base 20 system with groupings of 5 that was presented vertically. The Mayans are also the first known people to have used 0 as a placeholder. Early Chinese numerals were presented with alternating red and black rods. Their base 10 system is notable because the use of columns and rows for organization simplified addition and eventually led to the invention of the abacus. Math's diversity extends far beyond ancient times and can be seen today in the many ways equations are solved around the world. Here we have the equation 23 multiplied by 51, executed in the style typically taught in the United States today. We begin with the ones column on the right and move left, carrying the 1 of any number over 9 above the next column to be added in. We get the answer of 1,173. There are many other ways to solve this same problem. In Egypt, they developed a doubling algorithm to solve multiplication problems. To solve for 23 times 51 here, we begin with 1 and double until we are going to pass 23. Then, in the second column, double beginning with 51. By determining which numbers add up to 23 in the first column, we add the corresponding numbers in the second column to find the answer to the equation, 1,173. In China, many use this technique, where you draw lines for each digit you're multiplying, changing directions for each number. By counting the places where the lines intersect and putting these answers together, adding the numbers in the same column, we get our answer, again, 1,173. This algorithm from Belize is somewhat similar to the one used in the United States. However, the multiplication is done beginning with the numbers of higher value, moving from left to right. Again, we arrived at the correct answer, 1,173. Although usually taught separately from classes in the social sciences and humanities, math is indeed a cultural artifact. Math has a rich and complex history. It is taught, understood, and utilized differently around the world. Regardless of what may seem easier or more simple to one person or another, as long as it reaches the correct answer, there's no essentially right way to solve a problem. An understanding of ethnomathematics and cultural diversity in all areas can only help us to understand the way math and history surround us every day.